Hey everyone, and welcome to This Explainer. Today, we're going to fundamentally shift how you approach building data systems. Seriously, if you've been feeling totally overwhelmed by the literal sea of new software and applications constantly flooding the market, you are in exactly the right place. We're going to take a step back, zoom out, and shift our mindset away from highly specific individual tools. Instead, we're focusing on overarching foundational system architectures. We're going to map out the 7 essential patterns that actually drive modern data engineering.
Okay, let's dive straight into this. Listen to this quote. Most data engineers learn tools. Senior engineers learn patterns. This is the core thesis of our explainer today. Because in the real world of data engineering, your ultimate success is rarely going to be about exactly which brand name tool you deploy. True success, that's about choosing the absolute correct architectural pattern for the specific problem you're trying to solve. Look, tools come and go, right? They get updated, they get replaced, but patterns are the fundamental blueprints of problem solving.
And trust me, the stakes for getting this blueprint wrong are incredibly high. If you choose the wrong architecture, you're basically inviting in these 5 very real nightmares. You're going to hit scalability bottlenecks where your system just completely chokes under pressure. You'll suffer from high latency pipelines, meaning your data is just always arriving way too late. You'll bleed unnecessary costs. You'll wake up to total governance nightmares where absolutely no one knows who owns what. And ultimately, you'll be left with fragile downstream systems that just break the moment a slight change occurs. Those are the stakes we're dealing with. So here is our roadmap for today. Number 1, tools versus patterns. Number 2, mastering time and speed. Number 3, structuring for quality. And number 4, scaling systems and teams. All right, let's jump into section 1. Tools versus patterns, the senior mindset. It is so incredibly easy to fall into what we call the tool trap. Thinking the absolute shiniest new software out there is going to magically fix all your data pipelines. But remember, tools like Spark or Snowflake, while they are incredibly powerful and important, they're simply the implementers. They're just the vehicles. The architectural pattern is the engine. Success equals matching that specific engine to the actual terrain you're trying to navigate. Moving on to section 2, mastering time and speed, batch versus streaming. Now, this brings us to a massive fork in the road, batch processing versus streaming. Think of batch processing as your reliable, heavy-duty freight train. It handles high-volume transformations on a very steady, scheduled basis, like, say, calculating your daily sales reporting. It's simple, it's really cost-effective, but it does introduce latency between when the data is created and when it's actually available. Now, compare that to streaming or real-time processing. This is your high-performance sports car. You use this when milliseconds absolutely matter, like in fraud detection or IoT analytics. It continuously ingests data for instant reactions. But the major trade-off here is that it requires far more complex infrastructure. Just to ground these two patterns in the real world for a second, let's look at the tools that typically power them. For your scheduled batch processing, you're usually looking at data sources moving through ETL tools like Spark, managed by Airflow, maybe transformed by dbt, and landing in a warehouse like Snowflake, S3, or ADLS. But if you're building for streaming, you're dealing with event sources continuously flowing through something like Kafka, processed on the fly by Flink or Spark Streaming, and serving rapid-fire data to Redis, ClickHouse, or Databricks. But what if you actually need both? Well, enter the Lambda architecture. This pattern beautifully bridges the gap by acting as a unified analytics platform. It runs a batch layer, powered by something like Spark, to ensure perfect historical accuracy. But simultaneously, it runs a speed layer, using those streaming tools to cover the most recent data. Merging both gives you a completely unified view. But a quick warning here, integrating tools like Kafka, HBase, Presto, and Redis all at once, that makes this pattern operationally pretty complex to maintain. All right, section 3, structuring for quality, Medallion and CDC. Let's talk about the Medallion architecture. This is a wildly popular data lakehouse design that organizes your data into 3 progressive layers. First up is Bronze, which is your raw, ingested data. Think of this as basically just dust that happens to have some gold in it. Next, it moves to Silver, where it gets cleaned and validated. Now you've got pure, refined gold. Finally, it gets crafted into Gold, where it's beautifully curated specifically for analytics. These are your finished ornaments. The absolutely crucial point here is that you are incrementally improving data quality at every single stage of the process. And because absolute quality is the end goal here, this layered design relies heavily on governance. To move data from Bronze to Silver to Gold effectively, engineers utilize tools like Delta Lake and Databricks,
They apply massive processing power with Spark, and they enforce incredibly strict data quality and governance using Unity Catalog, Great Expectations, and dbt.
But how do we actually get data into these lakehouses efficiently, without completely breaking our source systems? That is exactly where Change Data Capture, or CDC, comes in. CDC tracks row-level changes in your source transactional databases and propagates only those specific changes downstream incrementally. So why does this matter so much? Because doing full table scans every single time you want to sync your database is just heavy and fragile. CDC completely minimizes the load on your source systems.
Now, executing this kind of incremental replication definitely requires some precision. To capture that CDC stream and push it perfectly to your data warehouse or data lake, you'll typically see tools like Debezium and Kafka acting as the bridge. This is usually right alongside powerful replication enablers like Azure Data Factory, AWS DMS, Fivetran, or Airbyte.
And finally, Section 4, Scaling Systems and Teams, Event-Driven and Mesh.
When you really need to scale massive systems, like, say, huge order processing networks, you're often going to turn to an event-driven architecture. In this setup, components communicate asynchronously via events. This essentially completely decouples the producers of data from the consumers of data using an event bus or a message queue. It makes your system highly scalable and incredibly resilient. However, a fair warning on this one too. Because everything is decoupled and flowing via tools like Kafka, AWS SNS or SQS, Azure Event Hub, or Cloud Pub Sub, it becomes a lot harder to trace a single event end-to-end.
And that brilliantly leads us into our final pattern, the data mesh. Now, this isn't just a technical architecture, it's an organizational one. Instead of having a central team bottlenecking all the data, Domain A, Domain B, and Domain C independently own and serve their own data as products. They're unified not by some massive single database, but by data contracts and federated governance. For really large organizations, this approach scales infinitely better than centralized platforms.
But let me be crystal clear here. A data mesh demands incredibly strong organizational discipline to actually work. You are quite literally trusting domain teams to be responsible data owners. To enforce that federated governance across the entire organization, engineers have to lean heavily on really robust data cataloging and governance tools. We're talking about things like Data Hub, Atlan, dbt, and Calibra.
Wow, okay, so we have journeyed all the way from the high-speed tracks of streaming and the complex unification of Lambda, through the refining fires of the Medallion architecture and CDC, all the way to the massive organizational scale of event-driven systems and the data mesh. Remember, your tools are just the enablers. Your true power as an engineer lies in the pattern you select. So I want to leave you with this thought to reflect on. Look closely at the specific challenges your team is facing today. Which of these 7 patterns is the missing blueprint that will finally solve your biggest data bottleneck? Thanks so much for watching this explainer, and keep building with intention.